So this is a min-max problem, and it's all about a cone. And they give you all of the formulas down here, and you have to know that the volume of a cone is 1/3 the volume of a cylinder. So it's 1/3 pi r squared h. But before we get there, we're going to have to show that, hey, there's no r in here. We've got to find a way of figuring out r in terms of h. Well, you know by Pythagoras that r squared plus h squared is 12 squared. So that means r squared is 144 minus h squared. And that's all you do to get this formula here. Instead of r squared, you put in 144 minus h squared, and you just multiply it out. 1/3 pi times 144, that gives you the 48 pi. And then there's an h multiplied. There's where your 48 pi h comes from. And then you go 1/3 times h squared times 1/3 pi times h squared times h. Well, that's why it turns into h cubed. And there it is, minus 1/3 pi h cubed. There, we've just shown exactly why that's true, why that formula works. The whole point of this was putting everything in terms of h. Now, the next step is we want to find out the maximum. All you do is take the derivative and make it equal 0. So we take the derivative with respect to h. We get 48 pi. 3 times a third is 1 minus 1 pi, and you subtract 1, h squared. Hey, they made it work out all nice for us here. And now what do? Well, you divide everything by pi, you add h squared, and you just take the square root of 48. And the answer is 6,93 centimeters. And that's it, all done.